Okay, now we're going to be introducing some new topics. Uh, Arcs, sectors, chords, secants, tangents, and it all relates to circles, parts of circles, or lines in circles. Okay, students will learn find and naming arcs. So the arcs are parts of the outer circle. So notice in yellow highlight, I have it yellow highlighted between A and B, and how you would name that arc is uppercase A, uppercase B with an arc over it. And then you can see the blue highlighted arc that goes from A to C, and this is how you would indicate that arc. So instead of this, which would not make sense, usually if you had a line segment and you were talking about this whole thing, you would just call it that. But with arcs, we would include the different parts. Okay. We include the 3 letters that it extends. Okay. Arc lengths. So if you needed to find the measure, well, here's something that's interesting. So an arc length is formed when you have a central angle. This is a central angle, and 2 radii extending to the circle. That yellow highlighted area, or I'll put it in red, this right here is an arc. And by the way, this arc measure right here is the same measure as the 60 degrees, except for when it's a length, we have to put 60 degrees in radians, and this is how you do that. When we have to, this is an angle, this is the arc measure. They're the same measure, so you have to do a conversion. So notice we multiply any angle, doesn't just have to be 60 degrees, by pi over 180. At least that's one way to do it. Some people do 360 pi divide 2, but 2 over 2 pi divided by 360. But that simplifies to pi over 180. So I just want you to do it like this. Now look at 6 goes into 18 3 times, so 60 goes into 180. 60 goes into 60 once, and 60 goes into 180 3 times. So what we have is 1 times pi is pi, and over the denominator, now the denominator is 3. So this 60-degree angle right there is the same measure as pi thirds. But this is in radians. It's actual a length. So it's 3.14 divided by 3 is the estimate. All right. So, and then here's the formula. So you take that theta right there, which is pi thirds, and you multiply it by the radius, which is, in this case, 1 unit. So what we have is that arc length is pi thirds units. That's it. And that's the exact. Now, if you wanted to find the rounded on your calculator, just do pi divide 3, and that will give you a decimal amount, and then put that right there. But I would like it to be the exact measure. I want to see the pi. So that's arc length. Now we're going to find the area of a sector, and that is the area of the circle that lies within the 2 radii that form the arc. So again, we have 60 degrees, and a minute ago we converted that to pi thirds, but this is now the area to find the area formula. So it's the theta Whoops. Let me go ahead and erase this to match up there. Or another way to say divide by 1/2, instead of that, we can just multiply this whole thing by 1/2 like that. So I'll do that. So 1/2 times our theta is pi thirds. Our radius is 1 unit. And then we square that. So pi thirds, 1 squared is 1. Unit squared is unit squared. So 1 times pi third is pi thirds. So this in here, all is just pi thirds unit squared. But then we have to multiply that by 1/2. Well, 1 times pi is pi. 2 times 3 is 6. So the area of that sector is pi 6 unit squared. And if you want to know the approximate, just do pi divide 6 and then put unit squared. Okay, that's area of a sector. Okay, now we're going to talk about central and inscribed angles. So a central angle, it starts from the center of the circle and then extends 2 radii, and this angle right here, right there, is a central angle. And if it's a central angle, this measure in degrees will be the same as this measure. So the measure of the central angle in degrees is the same as the measure of the arc in radians, meaning there'll be a pi involved. All right, so for example, this right here is a straight angle. It's 180 degrees. So 180 degrees, so think about this. If you have a circle, all the way around is 360 degrees. All the way around is 2 pi. So half of 2 pi is pi. So this arc length is an arc length of pi, and the angle measure is 180 degrees. I don't know if that helps at all, but that gives you an idea of what we're talking about. I'm going to erase all of that. All right, then we're going to talk about inscribed angles. So remember, these two measures are the same. The angle is the same measure as the arc. When we talk about inscribed angles, the inscribed angle sits on the outer part of the circle, not the center of the circle. And then it has these lines that also extend to the outer part of the circle. Those are called chords. So this is a chord, and this is a chord. And this angle right here is equal to 1/2 of the measure of the arc. So this angle forms this arc via these two chords. And this angle right here, this angle measure, is the same as 1/2 the measure of that arc right there. Okay? And then, so again, finding the angle or arc measure. Central angle measures. The measure of the central angle equals the measure of the arc it intercepts in radians in degrees. Okay? And then So yeah, this is 90 degrees. So this arc length right here would be pi halves. So see, 90 goes into 180 twice. So pi halves. So pi halves and 90 degrees are the same measure, but one is in radians and one is in degrees. And then the inscribed, the measure of an inscribed angle equals 1/2 the measure of the arc that that angle intercepts in radians, meaning there's a pi involved. Okay, I'll leave that up for a second, or you can pause. All right, now we're going to come down here to distinguish between chords, secants, and tangents. So chords stay within a circle, but their endpoints lie on the circle. So point A is on, I'll call this circle. Here, let me do this. Point A and point B both lie on circle with the center point being P, and then there is a segment that extends between them. That segment is called a chord, but notice the endpoints have to lay on the circle. A secant has 2 points that lie on the circle, but the line can extend. That segment can extend. So it can either be a segment that extends, and typically it is, rather than a line. It could also look something like that. The segment could end right there. But this is called a secant. One or both parts have to extend beyond the circle, and that's what makes it a secant. A tangent is a segment or a line that touches the outer part of the circle in exactly one place. And if it's tangent, it creates a 90-degree angle from the tangent line to the radius. Okay. So let me say that a little more clearly. The point of tangency forms a 90-degree angle with where it touches the circle at the radii. Okay, all right, that's it for this video explaining kind of the terminology, and then the next videos we'll actually get into doing the work.